Hello everyone, welcome to this channel. If you're new here, my name is Muhammad Hasan. Let's begin our 9th part of the video series. But before that, let me say that I couldn't upload these videos for a while now because of a great cyclone attack in our city of Kolkata. And all the internet network was interrupted. Things are slowly recovering and the internet connection is back now. And hence I'm here again to make you a bit smarter in the subject of physics. Today we'll be building a solid concept on the topic of real and apparent depth and its relationship with refractive index, and finally I'll navigate you through some numerical problem to make the concept super solid. So let's begin by rolling the intro. Okay, so let's start our study on the concept of real and apparent depth. So this is a very easy concept. We'll be looking into the concept and some of the proof related to this, and we'll be solving some MCQs or numerical based on real and apparent depth so that the concept is absolutely clear. So what is real depth? Real depth is actual depth and apparent depth is false depth. Now what do I mean by that? It will be very clear. Let me draw this thing and things will be easy. Suppose this is the bucket and in this it has water. Okay. Suppose we have kept a coin here. Then we will say that the coin is at certain depth. So this certain depth that we are talking about is actual depth. Okay, this is the actual depth. That is the actual depth in which the real coin is actually lying. Now, but when we keep our eyes here and look into this coin, then we will see that the coin is somewhere here, that the coin has moved up. Now, this depth is known as the apparent depth or the false depth. Okay. This is not the actual depth but the false depth which our eyes sees. So what is the relationship between real depth and apparent depth and how it is related to refractive index? We will look into that. Okay, so let's see. There is a proof. So this experiment will give us the relationship between real depth and apparent depth, and how is apparent depth related to refractive index. Now look into this figure and things will be very easy. Now, if you look into this figure, you'll see that this is the beaker, as you can see, and it has water kept into it. Okay. Now, this is the water. So there are two medium. One is air, another is water. Okay. Now, we have kept a coin here at the bottom of the beaker. Okay. So this d, small d, is actual depth. Okay. That is the real depth of the coin inside the bucket or the beaker. Okay, this is clear. Now we need to find out what is apparent depth. Now we know that for image to form we require two rays, as I have discussed earlier. So we'll be taking two rays. The first ray is this one, number 1. Now this ray will move in this direction because we know in order to see the image, rays should come from the object and enter our eye. Then only we can see the object. Therefore, this is the first ray that is moving towards our eye. But since this ray is moving from water to air, now water is optically denser and air is optically rarer with respect to water. Therefore, we know the concept that whenever rays move from optically denser to optically rarer medium, then the rays after refraction move away from the normal. As you can see that after refraction, this ray is moving away from the normal. Okay, simple as that. So this is our first ray. Now the second ray is drawn in white color. Let me pick another color in order to explain the concept. So this is our second ray. Okay, so it is moving and hitting the interface perpendicular. Okay, therefore after refraction there will be no deviation since incidence is normal to the interface. Okay, this is clear. So this is our second ray. Now in order for the image to form, we need the intersection point. So we got the intersection point, that is our eye will see that that is ray number 2 and ray number 1 is actually coming from some point, and if we just meet this point, we will get a point which is this point. Okay, so this is the point where our eye will see that the coin is there. Okay, so this is how your brain functions, simple as that. Okay, so this height where we are seeing the coin formation is actually d dash, and this is the apparent depth or the false depth. Now what is the relationship between this real depth and apparent depth? How to find out this? This can be found out using the concept of Snell's law. Okay, This thing has been explained in my earlier video, the concept of Snell's law. If you haven't checked that video, then I will put a link in the upper right corner, or you can check in the description below. Okay, from Snell's law we know that mu2 sine I is equal to mu1 sine R. Now mu2 is the refractive index of water and mu1 is the refractive index of air. Okay, so simple as that. Angle I is the angle of incidence, as you can see, this one. Okay, and angle R is this one. Simple as that. So our equation of Snell's law is ready. Now let me rub this off in order to make things clear. Now there is a mathematical concept here you need to understand. There is an assumption that you need to know. And the assumption here is that when theta is very small, we can say sine theta is equal to tan theta is equal to theta. Now I can explain this why this happens, but then the purpose of this video will get interrupted and I will sidetrack into another thing. So I don't want to do that. Just remember sine theta is equal to tan theta is equal to theta when theta is very small. Okay, now why theta is taken small here? Now if you look into this diagram, you can see that the eye that I have drawn here is very big. Normally our eye is not this much big. Therefore, if our eyes are small, we know that our eyes are small. So if our eyes are small, then angle R that is subtended and angle I that is subtended that will be created will be very small. Okay, since the angle I and angle R will be small, therefore sine theta will be very small. That is, theta of sine theta will be small. Therefore, sine theta can be taken as tan theta and that can be taken as theta. And now we know that tan theta is equal to perpendicular by base, as you can see here. We'll be using this concept. Okay. Therefore, equation 1 can be written as, now this equation that I've written here, that is mu2 sine I is equal to mu1 sine R, can be written as, now sine theta got replaced by tan theta and sine R is replaced by tan R. Okay, so mu2 tan I is equal to mu1 tan R. Now we know tan theta is equal to perpendicular by base. Now let's understand. Now mu2 remains same. Now how tan I becomes mn by no? Now let me write it down. In the triangle MNO, if you take angle I as the reference angle, then we will see that MN is actually the perpendicular and NO is actually the base. So we can say MN is perpendicular and NO is base. Similarly, when we are taking tan R, we will take the triangle XYO. Okay, in triangle XYO. Now look at this diagram again. If this is angle R, then this will also be angle R. How? Because this angle and this angle are corresponding angle. Okay, therefore if that is angle R, this has to be angle R. Now if this is angle R, if you take this angle R as reference, then we can say the perpendicular is actually YO is taken as perpendicular. Okay, and XY is taken as base, isn't it? Now if you look into the diagram, you'll see that YO is same as MN. So YO is equal to MN from the diagram. Therefore, we can say that YO is MN, that is perpendicular, and base is XY. XY is simple. Okay, now if we just arrange this thing, that is mu2 by mu1 is equal to MN got cancelled. Therefore, we got NO by XY. Now, what is NO? Look into the diagram. So, NO is nothing but the actual depth. See, this is O and this is N. So, NO is actually the actual depth, and XY, if you look into this diagram again, XY is actually D dash, that is apparent depth or the false depth. Therefore, we can write that mu2, this formula is important, mu2 by mu1 is equal to real depth by apparent depth. Now, the most important part where students confuse. Okay, just concentrate here. Now, always remember one thing, that the medium, this is very important. I've written some quick note. Just put a star mark here and remember, the medium in which the object is kept, whose apparent depth we need to find out, is always taken as second medium. Always remember, since the coin is kept here and the coin's apparent depth we need to find out, therefore the coin is kept in water. Therefore water will be taken as second medium. This is what I'm trying to say. If water is taken as second medium, then the refractive index of water will be mu2. Okay, so this is what I'm trying to say, that the object whose apparent depth we need to find out, then we need to check in which medium is that object kept. That medium in which the object is kept is to be taken as the second medium. Therefore, its refractive index will be denoted by mu2. Therefore, the remaining medium will be taken as the first medium and its refractive index will be mu1. Therefore, mu2 by mu1 is equal to real depth by apparent depth. So never confuse which one should I take as mu2 and which one should I take as mu1. This is clear. Okay, just remember this point. This is very, very important. So if you understand this concept, all the thing that I have showed you, all the concept and all the important part, then you can solve any question using this formula, that is mu2 by mu1 is equal to real depth by apparent depth. Using this formula, you can solve any questions that they throw from this concept. Okay, any question from this concept can be solved by this formula, that is mu2 by mu1 is equal to real depth by apparent depth. Now I will be giving you some numerical in order to solidify the concept that I have talked about. So let's move on and check some numericals. Now let's look into this problem. This problem will help you to understand which medium you should take as second and which medium you should take as the first. Okay, this is very important problem. So let's analyze this, how to solve these questions very quick. Now this is the situation where it says this is bird and this is fish. Now the bird is 36 maybe meter above the sea level and the fish is 24 meter below the sea level. Okay, now the question is find the apparent depth of the fish as seen by the bird and find the apparent depth of the bird as seen by the fish. Okay, now let's see how to solve this thing. Now look into this first question. It says that the apparent depth of the fish. So we need to find the apparent depth of the fish. Very important. So the refractive index, which one should be taken as the second medium? I told that we need to check which particle's apparent depth we need to find out. Here the apparent depth of the fish we need to find out. Okay, so the medium in which the fish is should be taken as the second medium. So very easy, since the second medium, the fish is in water, so mu2 by mu1 is real depth by apparent depth. This is the concept that we have learned, isn't it? Now mu2, since we need to find the apparent depth of the fish, so we need to take the medium of the fish as second medium. Therefore mu2 will be mu of water and mu1 will be mu of air. Now real depth, it's given that it is 24. We need to find out the apparent depth d dash. Therefore d dash is equal to 24. Now refractive index of air is 1 and refractive index of water is given by 4 by 3. So this will be 3 and this will be 4. Simple as that. Now if we solve this, we will get d dash as 18 meter. Okay, so 18 meter is the apparent depth of the fish. But don't stop here. There will be options like 10 meter, 20 meter, 18 meter, 54 meter. So don't just tick this and come. You'll get negative. Why? Because it says find the apparent depth of the fish as seen by the bird. Okay, the apparent depth of the fish as seen by the bird will be 36 meter plus 18 meter. Okay, if we add this, we'll get 54 meter. So this is the answer, not this one. Don't be in a hurry. Just look what the question is saying and then mark the answer. Okay, so simple as that. Now therefore you can see that the fish will be actually somewhat here. Okay, that is 18 meter. I hope the concept is clear. Now let's look into our second part of the question and things will be very clear and it will be solid. Now find the apparent depth of the bird as seen by the fish. Now we need to find the apparent depth of the bird. Now therefore we need to find out in which medium is the bird. The bird is in the air. So now the medium air will be taken as the second medium because the bird is in the air and whose apparent depth we need to find out. Simple as that. Now mu of air, that is the second medium, divided by mu of water, which is taken as the first medium, will be real depth. Real depth here is 36 and apparent depth is we need to find out. So d dash will be 36 into mu of water. Mu of water is 4 by 3 and that of air is 1. So if you just solve it, it's very easy. 12 and 48. So the apparent depth is 48 meter, but don't take this as the correct answer because it says that find the apparent depth of the bird as seen by the fish. The fish will not see it as 48 meter. The fish will see it as 24 plus 48 meter, isn't it? Therefore, if we add this, then we'll get 72 meter. So this is the answer, not this one. So be careful. I hope now the concept of which one or which medium should be taken as the second medium is clear. If you are clear with this, then you're good to go. You are in a good position. Okay, so this is all about the concept. Now let's look into our second problem. Now let's look into this concept, that is the combination of medium. We have learned combination in mirror, in resistance, and all those things. So combination is very important in physics. Now we know that for real depth and apparent depth, we only deal with two medium, not 3, 4, 5, 6. We deal with two medium. So here we can see that there is three medium, that is air, glass, and again air. So there are three medium or two interfaces. Okay, so how to deal with these kind of problem? Now the question is, find the apparent depth of the object as seen by the eye. Very easy, and the eye is located in this air medium. Okay, so simple as that. And the object is in this medium, air. Okay, so how to find out this? Very simple. Here we will again deal with combination. Okay, we have learned earlier in the combination of mirror that we will take the first combination, find out the result, and the result will act as a virtual object for the second combination. I hope this concept was clear back in our earlier videos of combination of mirror. Okay, so the similar concept we will apply here, that we will take, see, this is medium 1, this is medium 2, and this is medium 3 as of now. Okay, so this is one of the combination and this is the second combination. So what we will do is we will take this and this as our first combination, find the result, and the result will act as the virtual object for the combination of this and this. That is the second combination. Okay, I hope the concept is clear, and it will be clear, don't worry. So let's solve for the combination of 2 and 3, that is the glass and air. Now understand one thing, now the object is kept in air. Okay, and the object's apparent depth we need to find out. Therefore this medium will act as the second medium, that is this refractive index will be taken as mu2. Okay, and this refractive index will be taken as mu1. So simple as that. So mu2 by mu1, which is nothing but mu of air by mu of glass, is equal to real depth by apparent depth. Now real depth here is 10 centimeter. Okay, so 10 centimeter by apparent depth we need to find out. Just forget about this medium, just take into consideration this medium. Okay, now if you solve d dash from here, then we will get d dash is equal to 10 centimeter into mu g. Now mu g is 1.5 and mu of air is 1, so we will ultimately get it is 15 centimeter. Okay, therefore the object will be somewhat here. Okay, earlier it was 10 centimeter, now it will be 15 centimeter. Okay, for the combination of glass and air. Okay, this is clear. Now once we got this answer, therefore this position of the object will act as the virtual object for the combination of this one, like air and glass medium. Simple. Therefore we can solve again. Let's see, since the object, now this is one medium air and this is the second medium glass, but the object is kept in the second medium, okay, here. Therefore we can say that mu2 by mu1, that is refractive index of glass, because forget about air now, because we are dealing with air and glass, because we only deal with two medium in case of real and apparent depth. Only two medium, we play with two medium, not three. Okay, therefore mu2 by mu1, that is mu2 will be refractive index of glass, because the object is kept in the medium of glass, and this object is actually the virtual object, okay, for this combination. And mu1 will be refractive index of air, which is real depth by apparent depth. Now real depth will be, this is 15 centimeter and this is again 15 centimeter. So 15 plus 15 is 30. So we can write real depth is 30 centimeter and apparent depth we need to find out. So d dash will be 30 centimeter into refractive index of air, which is 1, divided by refractive index of glass, which is 1.5. Now if you solve this, then we will get 20 centimeter. Simple as that. Therefore the object will be somewhere here, like 15 centimeter, and this will be 5. So 15 plus 5, we will get 20 centimeter. Okay, the object will be here if we keep our eye in this medium. Simple. But don't mark this as the answer, because you need to see if the question was how much, at what depth will be the object from this interface, like the air glass interface, then your answer will be 20 centimeter. But since the question is find the apparent depth of object as seen by the eye, now the eye is 20 centimeter above the interface. Okay, therefore the apparent depth as seen by the eye will be 20 centimeter plus 20 centimeter, which is 40 centimeter. I hope the concept is clear. This is how you need to solve combination of medium in case of real and apparent depth. I hope the concept is clear. This is simple as that. Okay, now let's look into our final problem and we will wrap up the concept. Okay, now let's look into this question. This is the final question and we'll wrap up the video after this. Find the distance between final image, okay, and O. O is the object, this one, okay, as seen by the eye. So you need to find out the distance between final image and the object as seen by the eye. So this is a bit tricky, but we have all the concept that is required to solve this question. So let's understand. So this is medium 1 is air, and this is the interface between medium 1 and medium 2, and this is the second medium, that is glass, having refractive index of 1.5 as it is shown here. Okay, and this is the mirror having focal length, as you can see, 20 centimeter. So simple as that. So how to solve this kind of question? Let's see. Now we are observing from this position. Okay, so this is our eye. So let's see. Now if this is our object O, now this object will be seen by this mirror, isn't it? This object will be seen by the mirror and it will produce its image accordingly. Okay, we know that whenever an object is placed in front of the mirror, then an image is formed. Similarly, here the object is kept here and it is 10 centimeter from the interface, and from the interface to the mirror it is 45 centimeter. So you may be thinking that the total distance, that is the object distance from the mirror, is 55 centimeter. But the question is, will the mirror see the object at 55 centimeter? And the answer is no. Why? Because the object is in different medium and the mirror is in different medium, as a result of which the concept of apparent depth and real depth will come into play. Therefore, the mirror will not see the object at 55 centimeter, that is 45 plus 10 centimeter, but it will look at the object at an apparent depth. Now very easy. Now the mirror is looking at the object. Okay, therefore the object will have an apparent depth. Therefore, the medium in which the object is kept will be treated as the second medium, that is the air medium. Here, air medium will be taken as the second medium. Therefore, refractive index of air will be taken as mu2. So let's find out mu2 by mu1, which is the refractive index of air in this case divided by refractive index of glass, is equal to real depth. Now what is the real depth? From the interface we can see the real depth is 10 centimeter, isn't it? But the mirror will not see it at 10 centimeter. So that is the real depth, 10 centimeter. And the apparent depth we need to find out. So simple as that, d dash. So if you find d dash, then we will get 10 into refractive index of glass is 1.5 divided by 1. So if we solve this, we will get 15 centimeter. Okay, the object will be formed at 15 centimeter somewhat here. Okay, if this is 10 centimeter, then the object will be here 15 centimeter. That is, the mirror will see the object at 15 centimeter from the interface. Okay, so this is 15 centimeter. I hope this much is clear. Therefore, the mirror will feel that the object is at a distance of how much? So we can say the object distance u is actually 15 plus 45, which is 60 centimeter. Simple as that. So you got u, that is the object distance is 60 centimeter. Therefore, where will be the image formed? Very easy, mirror formula. V is equal to, we know that V is equal to UF divided by U minus F. You need to remember this formula in order to solve this kind of question very quickly, okay? I have told you to remember this. So U is, again, we got 60 centimeter, but according to sign convention, it will be minus 60. I won't explain why. Just go and see the video on sign convention that I have taught earlier. If you have forgotten, then. If you haven't forgotten, then it's okay. Focal length of the concave mirror is minus 20 centimeter divided by, now U is minus 60 minus and minus become plus, so 20. Now if you solve this, we will get 1200 divided by minus 40, and this will be equal to minus 30 centimeter. Okay, so simple as that. So we can see that the image will be formed at 30 centimeter, that is somewhat here, that is this distance will be 30 centimeter, minus 30 centimeter in front of the mirror. Okay, minus 30 means 30 centimeter in front of the mirror, and the calculation should be done from the pole. This is the pole. Okay, so this is 30 centimeter in front of the mirror, as you can see in the figure. But the question is, what is the final distance between the image, that is this is our image, and the object? Okay, this is the object, as you can see here, as seen by the eye. This is very important. You need to understand why as seen by the eye is given. Now if you think that the distance between them is, okay, this is 10 centimeter given, and this is again how much? If this is 30 centimeter and we know that the total length is 45, this is 45, so obviously this has to be 15 centimeter. So you will think that 10 plus 15 will be the answer, that is 25 centimeter, and if there will be an option of 25 centimeter, if you take it, it will be wrong. So how to do that? Let's see. Now why 25 won't be the answer? Understand, we are looking at the image from here, okay, and we are at a different medium, that is this is refractive index of air and this is refractive index of glass, and the image is in another medium. Therefore even though this is 15 centimeter, the eye won't see this as 15 centimeter because it is in different medium, isn't it? So again the concept of apparent and real depth comes into play. So very easy. Now we are watching from here. Okay, look into the diagram. We are watching from here and the object is here. Okay, so since the object is in medium glass, therefore the refractive index mu2 will be taken as that of glass, isn't it? And this is real depth. Real depth is 15 centimeter, and the apparent depth we need to find out. So we can see that d dash is equal to 15 into mu1. Now mu1 is that of air 1 and mu2 is refractive index of glass because the image is in the medium of glass. Okay, so that is 1.5 it's given, so we can easily say that it will be 10 centimeter. Okay, now the object is formed somewhere here, that is 10 centimeter. Okay, things are becoming untidy. This is 10 centimeter, this length. Okay, so this length is 10 centimeter. Therefore the distance between the final image, this one, and O as seen by the eye will be 10 centimeter plus 10 centimeter is equal to 20 centimeter, and it will be not 25 centimeter. Okay, so this is a bit complicated problem. If you understand this problem, this complicated problem, then I can say that you have understood perfectly the concept of real depth and apparent depth. So this is all for this video. If you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.